Okay, so the first one, what you got? F of 4. So what do I do? What do I do? I replace x with 4, right? For the function f. Notice I give you two functions, but you're gonna pick the right one. So 2 times 4 minus 3, which is 8, minus 3, which is 5. Okay, that's old stuff. I think back in exam 1. Solve for x, mean I want x isolated. So first thing first, what should I do? Mm-hmm. Solve for x. Subtract the 2y, maybe right in black. Subtract the 2y, subtract 2y. So on the left hand side, negative 2y, positive 2y is gone. So I have 3x equal negative 2y plus 12. Right. And then because you want to isolate x, divide both sides by 3. Or basically divide everybody by 3. Like that. So x equal negative 2/3 y plus 4. Right. And the last one, I would suggest you simplify the phi on the top and the phi on the bottom, right? This one and this one, so that I have x. Oops, I have x plus 4 minus 4, which is x, right? Because the x and the 4 and the minus 4 cancel, so just x. You see this again. You see the number 3 when you do the inverse function. I'll give you a little sneak peek. If two functions are inverse, if you put one function into another, is the answer should be x at the end. Always, always, any function, as long as they are inverse of one another. Mike, I'm gonna mute you. Okay. So far so good. So that's just review. I want to see people here for this. Review. Okay. Okay. All right. Now we talk about composite function. Composite function, it means you put a function into another. Pull up my note. I do at home. Notation is f of f, well, g of f of x. So the input for g here, is now no longer x, no longer a number. It's the whole function, right? It's the whole function, which is function f. That's why it's called composite. You put a function into another function. Do you guys remember the Russian doll? You open it and there's a little one inside. I don't know what's it called. Yeah, I know what's it called, but yeah, it's kind of like the Russian doll. You open and then there's a little one inside, and then you open another one that's a little smaller one inside. Same thing with this composite function. You open up the function, you see another function inside it, right? And we're gonna say G composite f of x. That's how you read it. Okay. So let me open up my notes, see what I wrote here. Academic. It's 10.1. We stopped at 9.5 last time? Yes, we did. Okay. So I can rewrite and another notation. This is G and the little o of f of x. So these two are the same thing. These two are the same thing. They're the same thing. Okay. For me personally, I like this one. because it's easier to in terms of like visualize wise, right? You know that a function inside a function, as opposed to this notation, a bit more abstract. On the exam, I'm gonna give you this notation. However, I would suggest before you do anything, change it into this function, right? Into that notation. Okay. Or sometimes if I'm lazy, I can do like this. G composite F, and that's it. I didn't write the F. A lot of time when you go to higher math, people just don't write the X. They all the same thing. They all the same thing. Okay, so domain of G composite F of X. X is the domain of F. Remember, F inside G. So what if you look at this one right here? If you look at this one right here, what is the domain of F? What do you put in for F? What do you put in for F? What do you think? X, right? I put in X for F, and then whatever come out for F, I put it in for G, right? So X is the domain of F, of here, of, and F of X is the domain of G because G is the outside layer, the outside doll, the big doll, right? So so here, if I would draw this, I would draw like this. So I have X, which is my little input, tiny little number, any number. And then I'm gonna put it inside the machine F. When I say machine, I meant function. Okay. And then I got something, right? I got something. And then whatever I got is called F of X, right? And what I'm gonna do next is I'm gonna put F of X inside G, my machine G, right? And then output will be G of F of X. So again, F, so again, let me remind you, G of F of X is the same thing as G composite F of X, right? This means you input F of X into function G. That's what I mean. That's what I mean. It's not always G of F of X. It could be F of G of X. Doesn't matter. Just letter, right? This placeholder. So let me give you some example. Given F of X equal 3x minus 5 and G of X equal 2 minus x squared, I want you to find F composite F composite G of -1. Now, if I was you on the exam, I promise you have something like this, guarantee. If I was you, I would rewrite this as better notation. So F is, because F is first, so it's gonna be outside function of, and then what's the inside one? G of X. Right. So G of X is the smaller doll, and F is the bigger doll. We talked about it. By the way, it's not X anymore, it's -1 here, right? So the X is, this is your new X. This one is no longer, so that's your X, which is -1 in this case. Okay, so what does that mean? That means I have to find G of -1 first. And whatever G of -1, I put it back into F, right? So let's find G of -1. G of -1. What do? You plug in -1 for function G, right? So I have G of X is 2 minus x squared. So that means 2 minus something squared. And that something is -1. Maybe I'll write -1 left here. Okay. All right. 2 minus -1 squared is +1. So 2 minus 1 is 1. So that means what? That means G of -1 equal 1. And what do? You put that 1 for F, right? So this right here is equal 1. That's one is that one. right? So now what I'm going to do is, now you do f of 1, right? Because f of g negative 1 is 1. So what's f of 1? You plug in for the machine f, which is 3 times something minus 5, and that something now is 1, because that's your new input. 3 minus 5 is negative 2. Why don't you guys try B? You tell me what you got. People from Zoom, if you have the answer, put the answer in the chat for me, okay? Rewrite what I just rewrite the same thing I do, right? Which function is outside? In this case, both f are outside and inside. Thank you. Not quite, Devin. Not quite. Let me rewrite that first step that I always recommend you do. So it's gonna be f, which is this guy, right? And then this guy right here is also f, which is okay. That's right. And then we have -1 inside. Okay. Thank you, Devin. Does anyone have the same answers Devin does? What you got, Taylor? Yeah. Corey, -8. Thank you, Corey. I don't know which one is correct. Till I finish the problem. But I appreciate you guys try to work it out. So it's the same thing I do, right? Just follow the step. So f, you're gonna do from inside out. So start from the smaller function. So which is the inside, which is f of -1. What does that mean? That means you look at the function f. What is f? F is 3x minus 5, right? You add, you plug in -1 for x. So the function f is, say, 3 times something minus 5, and that something is -1. 3 minus 5 is -2. And now you work your way out into the red function, which is the outside one. So f of -1. So f of -1, we know that's -2. And again, we plug into the function f again, because that's what it asked us to do, right? So 3 times something minus 5 again, but the new input now is no longer -1, it's -2. -6, huh? Oh, yeah, that's right. But thank you. I was thinking of, no wonder I feel deja vu. It's the same thing as above. Thank you. Yeah, so -8. So let me change -8, -8. Thank you very much. 3 times negative 8 is negative 24 minus 5, negative 29. And that will be your final answer. So you guys get the gist now? Yeah, just work your way inside out. You try this one. Try A. Try A. Do the same thing I do. G3. Good, very good. Yes. There's a lot. Your parents. I don't have to. You may divorce your person, you never divorce your family. I know. Yes, I do. I'm not bound. So, very good. Very good. You were rationalizing. That's what I want to see in students. Do you remember the previous lecture? So you rewrite it. You rewrite it, do G of, so outside one will be G, right? You write this little guy. This notation is really difficult to understand. So rewrite it like I did. See how I rewrite F, which is the outside function, the red one, and then parenthesis, and then the inside function will be the next one. The outside will be no, the outside not F. The outside is the problem. The outside one is G. You start with G. Big parenthesis. So parenthesis, parenthesis. And then the inside will be the next one will be what? Another function which is I'll explain it. I'll explain it in because you missed the first part. All right. So what you got for answer? Nobody here. Taylor, what you got? Okay, very good. You rationalize it? Yeah. So so we start with the outer function, which is f, right? That's your biggest function. So I suggest you do f and then big parenthesis. Don't get the little parenthesis, you don't have enough space, right? And then G, which is your next one. And then the input of G, which is 3 this time, right? So 3. So G of 3, what's G of 3? We're gonna work from inside out. G of 3 is you plug in 3 for G, right? So G look like this. G say x squared minus 4. So something squared minus 4. And that something now is no longer x. So that was G of x. Right now we have G of 3. 3 squared, which is 9, minus 4, which is 5. Now G of 3 is 5. So that's your G of 3. And now you plug it into the F, the outside one, right? F of 5 now, which is F is 1 over square root of x, which is square root of something. And that something now is 5, no longer x. And I like it how Taylor and Hayat, they rationalize it. I'll use different color. I mean, I don't want square root under the denominator, right? On the exam, I do expect you to do this as well. So on the top, 1 times square root of 5 is just square root of 5. And the bottom, square root of 5 times square root of 5 is square root of 25, which is 5. You may lose a point if you stop right there. All right, second one. Again, you write what I wrote before, right? So the outside function will be G here, the first one. So G, big parenthesis, and then the inside one will be F of X. So F of X. Now, there's not a number. There's no values here. So what you do is you put the whole function F into G. Show the whole thing into G, right? So G is something square minus 4. Right? G is, which is something square minus 4. And that something now is no longer X. Is what? Is F of X. Right? It's F of X. It's no longer X, it's the whole function. So F of X is 1 over square root of X. Someone simplify this for me. 1 over square root of X squared, which is Curtis one. Yeah, 1 over X minus 4. I'll leave it like that. It's fine. You don't have to do anything else. Yeah, it's good enough. You don't have to do the common denominator. So far, so good. Yeah. My Zoomer, do you got any question? If you do, please ask. Now some of you are very. I'm. Consider we have a small class. I think I have a good group of people. at least in terms of like attitude wise, you guys actually want to learn, and half of you do well. I think I'm happy with half of you. The other half, I think you should spend more time with the lecture notes and homework. Okay, I think everybody have everybody are capable of doing good mathematics, and because math is they connected. If you lost a dot somewhere, it's hard for you to continue to the next level, right? So try to do your homework and look at my lecture notes, my video. You do well in the next exams. Okay? I like to see everybody pass the class. Such a small class, but I cannot help you if you have an F or a G. I can help you if you have a C minus. I can try to bump it to a C if you by doing extra credit in the class, but there's limit where I can help. All right, so that is composite function. Now we're gonna talk about one-on-one function and their inverse. Let me put my note. This is a difficult chapter, if you ask me. Okay, so the definition of one-on-one function is this. A function is said to be one-to-one. A lot of time people write like this, 1/1. For every x in its domain, there is only y in its range and vice versa. Do you guys remember the function and relation? Relation is easy, right? If you have an order pair x, y, everything is a relation. However, in order to be a function, what has What has it happened? Do you remember? Yeah, Kobe. Good. That means when you do the vertical line test, it has to be cut in how many times? At most once, right? At most once. So in order to be a function, you have to pass the vertical line test. In order to be a one-on-one function, which is even more stricter, you only have one x for every y and vice versa, right? In function, you can have repeat y, but one-on-one, you cannot have repeat y nor repeat x. Okay, so that given x squared, given f of x equal x squared, I want you to tell me, is this a one-on-one function? Well, tell me, is it a function first? By graphing this, right? You can graph this. Let me show you the first one. I'm showing you how to graph by hand. The next one, we use decimals or graphing calculator. So x and f of x is cos x squared. So when I choose, let's see, I'm gonna choose -1. I'm gonna choose -2, -1, 0, 1, 2. When x equal -2 parentheses square is 4. And then what? -1 square still is 1, 0 square is 0, 1 and 4. And then graph this. So -2, 1, 1, 2, 1, 2, 3, 4. 2 is 4. 1 is 1. -2 also 4. And -1 also 1. 0 is 0. You connect the dot. Try not to make into like, try make it a little curvy. Don't make it into like a, don't make it into like a V. That's the absolute value function, not, this is parabola. So make it a little bit curvy at the bottom. Okay, so first of all, is this a function? Is it a function? And why? Is it a function? Yes, right? Because it passed the vertical line test. If you draw any line, randomly draw any line, it only cuts it once. Is it a one-on-one function? Oops. Let's say yes here. Pass vertical line test. Is it one-on-one function? What give it a, well, it is not, but what give it away? Yeah, you have repeated y, right? You have repeated y. You don't want to see repeated y nor x. This is tricky. So because you have repeated y at where do you have repeated y? Right here, right here, right here, and probably even more if you add more points in it. So no, because y repeat. Y repeat, repeat. Now, if I draw a line like that, how many times it passed it? The graph. Any line, basically, and it doesn't have to be the right there. You can draw right here. You can draw right here. Any line, right? It cuts it at two points. Yeah, the only time it cut once is at the origin. But every time you draw a horizontal line, it's cut twice. So we call this the horizontal line test. Again, just like vertical line test, not supposed to be passing through the graph or 2 times or more. All right, number 2, we're not gonna do by hand. we're gonna using graph. I'll show you how to do the graphing calculator, so it'll be fast on the exam. Have I shown you how to graph function? F of x equal x cubed. So go to your graphing calculator. Let me clear that bit. So you see the y equal, the very top left, y equal, right? And plug in your function x cubed. So the x is the one from the third one from the second column right here. X t theta, because function is in the output x when you press that button. So x, and then q. Right. Then you now you go to let's go to the table first. So second window, if you press second window right here, second window, you go to table set. I think I talked about this, but I will remind you again. It's a table set. You should have your independent in as and dependent in auto for the rest of your life. Leave it like that. So that means you're going to input in X, and then the computer going to compute it and then output your Y. And then now quit as now second quit, and then go back to Y equal again. I want to graph, so hit graph. Second window. Do you have independence as ask? All right, so independence should be, the cursor should be on the ask, and dependent, which is the last line, should be auto. Yeah, and then hit graph. Right there, that's your graph y equal x cubed. It's like a railroad track. Right? It's like a railroad track. Let me copy that graph. Is it a function? I'll use red. Is it a function? Anyone? Is it a function? Yeah. Yes, right. Yes. Thank you, Corey. It's a function. Is it one-on-one function?
Yes, because it doesn't really
It's past.
it only crosses the x-axis once.
Okay, no. In order to be one-on-one function, you have to pass the horizontal line test, which is you only allowed to cut the function at most once, right? So just randomly draw one horizontal line anywhere. Oh, sorry. You think it's a one-on-one? I think so. No, I think so. Even though if you draw at the origin, it's still one-on-one. So one-on-one. Also yes, because it's past the horizontal line test. So the bottom line is for the horizontal line test, a lot of abbreviate as HLT. If every horizontal line intersects the graph of a function in at most one point, it is a one-on-one function. So remember on the exam, don't mess it up between the vertical and the horizontal. Make sure you know which one you use for what. Okay, you tell me. Determine whether each graph is a function. If so, whether it is one-to-one. The first one, is it a function? Yes. Is it one-to-one?
Yeah.
Yes, right. So function ID in blue. So function is f, and then one-to-one. Also yes. What about the second one? Is it the function? Is it a function? Yes. Is it 101? No, right. This one, is it a function? Is it 101? If you are not function, you stop. Yeah, if it, so function is function no, function is no. So you stop. If it's not even a function, don't even think about it 101. Right? You have to pass it to be able to be a function first. What about the last one? Okay, the last one is kind of deceiving.
It's no, right?
Is okay, is it a function first? Is it a function? Yes, right? It's yes. Is it 101? I know it's not your fault if you say it wrong. If you answer it wrong, I'll tell you why. Is it 101?
Well, I don't want to say it.
Okay, so it says yes. It is 101. But some people say, Mimi, if I draw a horizontal line right here, it looks like I'm passing through the graph infinitely many times, right? It's not true. This graph is called exponential growth. This is how you see virus and bacteria.
That's the one I never touched.
Yeah, it's never quite flat. That's a slope. So you never cut it twice. Maybe I'm gonna do this. I'm thinking next semester I'm gonna stop like letting people zoom in. It's a lot of work for me. Oops, what happened? I got kicked out. Okay, no, I'm getting it. Desmos. One of my favorite websites. It's called the exponential. Oh, exponential function. Yeah, put this down. If I zoom this out, oh, my call. Oh, darn it. Oh, Control Z. Y equal e to the x. Come on, come on. E to the x. There you go. I forgot how he showed me how to zoom this out. Doing, Yeah, if you zoom it out, you see that it's never quite touched the x-axis. Never. Yes. Keep zoom in. See, it never did. And it's there's a slope, so you never cut that graph twice. Later, we're gonna talk about this graph. Very important, very useful too. Have you seen? If you hear about a video going viral, this is what happened. The number of viewers is just shot up to the sky. Right? Share. I need to talk to the IT department. All right, what about this one? A little bit different. Remember the definition. Oh, first of all, is it a function? Is it a function? Name on the left and birthday on the right. So basically, on the left will be your x, on the right will be your y. This is your x and this is your y. Is it a function?
No.
Remember what the definition of function? You cannot have repeat x.
Repeat X.
Yeah, repeat x. So you have repeat y, which is okay, right? In the class, you can have two per person with the same birthday, which is fine. So yes, it's a function. Is this one-to-one function? No, right? What about the B? What about B? Is it a function? No, because yeah, X repeated, right? So people have two cell phones. So nope. If it function doesn't pass a function, then you stop. Okay, so now so that's the 101 function. Now inverse, they're inverse. If the function are 1-to-1, then it has an inverse. Let me repeat that. 101 and inverse, they not mean the same. It means that if you are 1-to-1, if a function is 1-to-1, then it must have an inverse. Only 1-to-1 function has inverse. So what does inverse mean? Inverse means if f of x is a 1-to-1 function whose order pair are of the form x, y, nothing new there, right? Then is the inverse of f, which is denote f inverse of x. I know it looked like the f to the -1, but it's not. It's called f inverse. Is the set of order pair yx. So if you look at the definition, that means what? What happened to domain and range of f and f inverse? Swap. Swap. So for example, let's take an example. Maybe it's more intuitive. If f of x equal 2x and then g of x equal x over 2, show that f and g are inverse of one another. I'll show you the what they call it, the brute force brute force way. That means pick a number, plug it in. So I'm gonna say let me do f first. I'll pick 1 for the domain. If x is 1, then what's y? If f is 1, then what's y? Plug it in. 2 times 1 is 2, right? 2. Maybe I'll do the same thing with g at the same time. So 1 for g, you plug in there. 1 over 2 is 1/2. 2. You guys fill that in. Maybe it doesn't have to be 1, 2, 3. Any number you want, really. Just make it easy. You fill that in. Okay. All right, so if f is 2, 2 times 2 is 4. If f is 3, 3 times 2 is 6, 4, 8. What about g? G, if f is 2, then it's 1. 3 is 3/2. 4 is 2. You know what? I don't like the fraction, so I'm gonna pick 0. I'm gonna pick no. Let's do f first. It wasn't wrong what I did. It just it's not the good way to explain it to you. So let's do f first. So that's f. Now g, if g is the inverse of f, if you want to prove that g is inverse of f, then the domain of f and g is going to be swapped, right? So if 1, 2, then you should have what? 2, 1. Is it true? Let's check. If 2, 1 is true, 2, 1. That means when you look at the function g, if you plug in 2 for x, 2 divided by 2 is 1. Sorry, I got excited. I erased the whole thing. So choose 1, so that check. What about 2, 4 now it's become 4, 2. Is it true? You plug in 4 for x, 4 divided by 2 is 2. So yes. What about 6, 3? Is it true? So 6 divided by 2 is 3. Yes. What about 8? 8 and 4. Also true, right? So what does it tell you? What does it tell you? The domain and range is swapped, and you check it's true. So that means This imply F and G are inverses of one another. One another. So let me give you a little note here. Maybe I'll write in purple remark from the definition. Up here, so I have more space. Domain of F is equal to the range of G, and the domain of G is the range of X of F. They swap. Right? Notation, and please don't get this wrong. If I say inverse of F, then you write it as F, and then the negative one is on the top, but you don't want to say it like that. F inverse is say F inverse, call F inverse, right? Now, be careful. F inverse is not equal to 1 over F. So you gotta remember this. Don't write this down. Don't write this part that I'm about to write down. A to the negative 1 is what? From what you learned, A to the negative 1, if you want to get rid of 1 over A, right? We talk about exponential rule here, right? But here is no exponential involving. It's just notation wise. I know it's confusing, but there's no relation between the two. F inverse is not 1 over F. Right, example. And again, we're not gonna use this way. I'm just showing you this, just to, I don't want to say prove the definition, but it's not the way how I want you to show F and G are inverse. Okay, I'll show you another way. All right, now if F and F inverse, then if you put F into F inverse, then your result should be F, should be X, right? And the same thing, if you put F inverse into F, then the result should be also X. Composite, you composite them together, your final result always X for every function that they give you, as long as they are inverse of one another. So it is the same thing as saying F composite F inverse is equal to F inverse composite of F. And can someone tell me how you would rewrite this? It's easier to understand like that, right? It's up there. Equal X. Okay, so now I'm going to show you that I want to prove that F and G are inverse of one another. By the way, G here, I know it's kind of confuse you, because I don't know G is the inverse yet, so I don't call it F inverse. So I just call it G, just some different letter. Like once you prove G's are inverse of F, then you're allowed to write the notation F inverse. All right, I'm going to prove a different way, good way, not the brute force. So, so this is what you want to prove, right? So what you want to show is that F of F inverse of X is equal to F inverse of F of X. And then your result should be equal to X, right? So let's do that. First one, F inverse of X. So what does that mean? Let me put the inside function in blue so it's easier for you to see. So F inverse. You know what? Let me replace F inverse with G so it's easier for you to imagine like that. Because right now with G, we don't know the inverse or not. Okay, G of X. What's G of X? G of X is X over 2, right? All you do is just plug in, replace G of X is with x over 2, put the equal. And now you plug x over 2 into the function f. So function f look like this, 2 times something, and that something now is x over 2. It's no longer x. 2 and then the 2 cancel, so that equal x. What about g of f of x? Why don't you guys do that? I'll walk around, see how you do. People from Zoom, if you got, if your answer should be x, give me a thumbs up or something like that. It's a long lecture. I cannot show you anything else. Yeah. Very good. Very good. Zoomer, homie, did you guys got X? Anyone? If you got X, just put your hand up. No, no, it's with X. All right. Okay. So let me start. Okay. So inside function first, right? So equal. This is equal g, and then the blue is now is 2x, right? And what do I do with the 2x? You put it inside g. G is something over 2, and that something now is 2x. Excuse me. Two cancel, equal x. So yes, you just prove that. You just prove f and g's are inverse. So that means you can denote g of x as f inverse. Okay. So far, so good.
Yeah, if this one is a test, could we just show circle x and x? Or do you want to start like the thing you were about? We put yes, g.
You can at least do this, or at least one of these, or at least do one of these. Yeah. Answer the question. How's that? Whatever they ask you. Yes, Toby.
Okay, so I'm a little confused.
Mhm.
What is all like the F of like the stuff that you're doing at the start? Like, and I know it might not be their problem, but for that one, you could just kind of look at them and tell that they were inverse of each other.
You cannot tell by looking. You have to prove. You have to prove. So that means, remember the beginning you had this part called composite function. So if you put one function into another, and you kind of switch them around, your final result will be x. Then that prove the two functions are inverse of one another. So the first one, I'm going to put g into f, right? So f is what? 2 times x. So g is x over 2. So now f, we replace the blue one g of x with x over 2. and you plug x over 2 into f.
Into 2x.
Into it. So f of x is 2 times x. Then f of x over 2 would be what? 2 times x over 2. So the f of apple would be 2 times apple. Curtis, 2 times Curtis. Whatever inside the parentheses, you replace with that little x. X just a placeholder. It doesn't look for variable.
So you just replace x with the other side.
Yes, yes. Whatever x is, you replace it with the difference.
Okay.
You know, long, I find that people have trouble. Either you get it or you don't. It's like politics. I don't know why about this chapter. Same thing with log, but there's no in between. You like it or you hate them. All right, okay. Here's the easier one. Given this, I want you to find F inverse. I say easy because what can you do? Yeah, just swapping around, right? That's what the definition of F inverse. So just swapping around. So 5, 1, 3, 2, 4, 7. I want you to do this at home. You may want to look it back here. You have something like this on the exam. So please watch my video or take a look at my lecture note. Let me do maybe one real quick. Okay, now I think a little bit easier now. I think that's the harder part. Not harder, but it's just tedious. Now I think a little bit better, a little bit more interesting. So if I give you f, I'm not asking you to prove g is the inverse of f. I want you actually find f inverse, right? So given an equation, I'm actually want you to find it. So the first step is replace f of x with y. So let me give an example. Example x cubed plus 1. So the first step, what do I do? So f of x equal that. So the first step is say replace f of x with y. So that means what? Now you rewrite as well what? Y equal x cubed plus 1. Right. The second step is you're gonna swap. Remember domain, they swap x and y. What does that mean? You swap x and y, right? That's what I mean. So now instead of y gonna be x, instead of x gonna be y, and then keep everything in its place. All you do is swap x and y. Don't do this. Don't put x cubed here and then y over here. Okay, that's not swapping. You're moving it, but it's not swapping. And now you solve for new y. Can you solve for y in that one? What do you do? What did you do? How do I solve for y? Subtract 1, right? Subtract 1 both sides. That's cancel. I have x minus 1 equal y cubed. How do you solve for y cubed? Cube root both sides. Cube roots, so make sure you have a little number 3 in index. So on the right hand side, it's just y. On the left hand side it's gonna be cube root of x minus 1. And the last step, almost done. The last one is the easy step. Replace y with f inverse of x. So this is f of x equal cube root of x minus y. We'll continue next time, but I want to give you a little taste so you can do your homework. You can do all the homework now. But next time we practice more, right? So pretty simple, replace F with Y, swap X and Y, and then solve. Anything else? Is there any question? All right. Then have a good one, and I'll see you on Wednesday. Oh, by the way, we have an exam on the August of 11. Okay, not 15, August of 11. From 9 to 11. Oh, F inverse, my bad, F inverse. Bye. Bye.
All right.
Okay, you too.